Hey guys, welcome back to 2014 Level 2 Physics paper walkthrough. We're gonna be carrying on from where we left off yesterday. Shouldn't be too much left, there's only like 5 questions left in the test. Shambhala drives a car at a constant speed around a corner. It then drives over some ice as shown in the diagram below. You can assume there is no friction between the ice and the tires. Describe the net force on the car, if any, before and after she reaches the ice. Explain how the net force, if any, affects the motion of the car before and after she reaches the ice. Okay, so basically, before she experienced the ice, okay, she was moving in the circular motion, okay, which means that there was a centripetal force acting on her, which is an unbalanced force. And because of this unbalanced force, this allows there to be change of velocity. Because change of velocity is a scalar, not scalar, it's a vector quantity. That means there's both magnitude and direction. So this means that the speed is the same, but then the direction of velocity is constantly changing. And because the velocity is constantly changing, there's an acceleration, and therefore there's an unbalanced force acting on the car, which is the centripetal force. Okay. However, and the centripetal force keeps her moving in a circle because it changes her direction, like always changes her direction. But however, when she encounters the ice, right, as it says in the question, there's no you assume there's no friction. That means as soon as she reaches the ice, there is a sudden loss of centripetal force. Okay, then that means all of a sudden there's no more centripetal force acting on her. Okay, so this means that means just suddenly going to be a loss of centripetal force. So there's no longer going to be any unbalanced force. So the forces are going to be balanced, and this means because the forces are balanced, that she's going to no longer be traveling in a circle, and that she's just going to drive off in a straight line to a tangent of the middle. Okay, so let's say this is the middle here. She's just going to move in a 90-degree angle. So just draw that here. Oops. So we can put this looking something like. Oh, no. Sorry, make this a bit. So she's just gonna move in a 90-degree angle, basically. So something like this should look something like this. Yeah, so just gonna keep going straight and then no longer go in a circle, because after she experiences in the ice, there's a loss of friction, which means there's a loss of centripetal force, and because the forces are no longer unbalanced, so the forces are balanced, then she cannot change direction. She has no longer any change in velocity, and because there's no change in velocity, she'll drive off at a constant speed in a straight line. Okay, because the direction isn't changing and the speed isn't changing either. Okay. So how are we gonna answer this question? Okay, we're gonna say no. So basically, the centripetal force causes an unbalanced force. Hence keeping her car moving in a circular motion. Okay. So basically, the centripetal force, there's an unbalanced force, and because it's an unbalanced force, okay, vector, sorry, not vector, velocity is a vector quantity, and this means it's both magnitude and direction. And because the magnitude remains constant, that means the direction is constantly changing, okay? And because the direction is constantly changing, that means this unbalanced force is allowing her car to move in a circular motion, okay? So, so basically, after So basically, after she hits the heights, there's a sudden loss of centripetal force, meaning the forces are now balanced, and that F net equals to 0. Because F net equals 0, there's no acceleration, and therefore the car is will drive off at a tangent of a circle at a constant speed. Okay. Okay, so F net equals 0 newtons and F equals ma. Therefore, the acceleration is 0 meters per second. Okay, therefore the velocity of the car is and because the velocity is constant, okay, that means it's a vector quantity, so that means both the magnitude and the direction is going to remain the same, okay, so it's not going to change anymore, okay, so basically the car will continue in a tangent to the center of the circle, okay, and the car will move at a constant speed as velocity is constant. Okay, so basically let me explain this one more time, okay. So, okay, before she reaches the ice, there's centripetal force acting on her. This is an unbalanced force, and this allows for a change in velocity, okay? Because the speed is remaining constant, okay? Therefore, the direction of the car will always be changing, okay? And because of the unbalanced force that's changing the direction of the car, this keeps the car moving in a circular motion, okay? So that's why she was moving in a circle, okay? So after she experiences the ice, okay, she suddenly loses the centripetal force, okay, so there's a loss of force, and then the forces become balanced, okay. So therefore F net equals 0. Because F equals to ma, that means there's no acceleration, and where there's no acceleration, we know that the velocity of the car is constant. So therefore, because the velocity is constant, that means the direction and the speed is constant, okay. Because both the direction and the speed is constant, right? That means she's not going to move in a circle because that's changing direction. She's just going to be moving in a straight line from when she loses the, so she's here, right? So I'm going to explain. So the car is here, okay? She's not going to move this way. She's not going to move in a circle anymore. She's gonna come, lose the force and then become straight line. So as shown by the arrow, she's just going to go in a tangent to the center of the circle, okay? And yeah, that's we have to say that the car speed is constant because the velocity is constant, okay, that's both magnitude and direction, so the speed is also constant, okay. So getting all the way down to here, that's explaining all the points I've covered, okay, will get you an excellence grade, okay. To get a merit, okay, you're saying that there's a friction force acting towards the car, but before she reaches the ice, and there's an unbalanced force that's causing her to accelerate, and you're saying that after she meets the ice, that there's a sudden loss of that force, okay, and to get an achieved, it's basically just one correct idea. So saying that there's a friction force, centripetal force acting on the car, or you can say there's an unbalanced force acting on the car, or you can say that after she collides with the ice, not collides, after she experiences the ice, there's a loss of centripetal force, or you can say that that the velocity of the car is constant, and the forces are balanced after she goes onto the ice. Okay, so any one correct idea will get you an achieve. So you can get merit for 2 correct ideas and an achieve for just 1. Okay. All right. Question 4. Sharmila drives home. Sharmila and the car have a combined mass of 1100 kilograms. Calculate the total momentum of the car and Sharmila when the car has a velocity of 18 meters per second. Include a correct unit of your answer. So looking at your formula sheet, you should know that P equals to mv. So momentum equals to mass times velocity. Okay. You know the mass is 11,000 kilograms and you know the velocity is 18 meters per second. Okay. So basically we can just say that 1100 times 18 equals 2. Plug this into your calculator, you should get 19,800 kg. Oh, that's a bad K. That's an ugly K, okay. kgms minus 1, okay. And that should be your final answer, okay. Remember the unit. This is the unit for momentum, kgms minus 1. And that will get you an achieved grade, okay. With the unit, will get you an achieved grade, okay. Calculate the size and the direction of the momentum change as the car slows from a velocity of 18 meters per second to a velocity of 11 meters per second, okay? Okay, so basically, we can say that the initial velocity, so P initial equals to 18 times 1100, and we worked out above that's equal to 19,800 kg ms minus 1, okay. And the velocity, so we know that pf minus pi equals to change in momentum. Yep. So we know that initial momentum equals to 1900, okay. So initial momentum is 19,800 kgms minus 1, okay. So final momentum would be 11 times 11,000 equals to pf. You plug this into a calculator. What we get? Sorry. So 11 times 1100, you get pf equals to 12,100 kgms minus 1, okay. Oh god, it's really squished. Okay, so you know that change in p equals to final momentum minus initial momentum, okay. So you can say that 12,100 minus 19,800 equals to negative 7,700 kgms minus 1. So basically, you should always leave your answers positive, okay. So you're gonna be saying that the change in momentum is equal to 7,700 kgms minus 1, but in the opposite direction, okay. Oh gosh, sorry, but in the opposite. So you know initially you had this minus, you had negative 7,700 kilogram meters per second, okay. But if you flip the direction, okay, so if you had, for example, this was moving to the right, okay, let's say it was negative 7,700 to the right, okay? So that basically means that it's positive 7,700 to the left, okay? So you flip into the opposite direction. So when you flip to the opposite direction, the sign also changes. So a positive will become a negative, and a negative will become a positive. So if you change the direction, the parity will also change, okay? So if you have negative 7,700, if you make it positive 7,700, you also have to flip the direction. So basically, you can say that the change in momentum is positive 7,700 kilograms meter per second, but it's acting in the opposite direction, okay? So basically, having both the correct direction, so saying opposite direction, and you have 7,700 kgms minus 1, you'll get a merit grade, okay? To get an achieved grade, you have the correct change in momentum, or you have the correct direction will get you an achieved. Either one of these will get you an achieved. Alright, next question. Explain the principle explain the principle of energy conservation in this situation and identify the transfer of energy caused by braking. Okay, so what is the principle of energy conservation? Okay, so what is that? That's basically saying that no energy is lost. Okay, so it's basically no energy is lost, but it's instead transferred from one form into a different form. Okay, and that none of this energy is lost during the process. Okay, so basically, you can say that you have to explain the principle of energy conservation. You can say this. So you can say you can say principle of energy conservation is that no energy is lost, okay? But it's just transferred into a different form, okay? So how is it relevant to this situation, okay? That's the question you have to answer, okay? So you can say that when she is braking, right, there's a friction force acting in the opposite direction, okay? And you have to think while she's braking, what's gonna happen? So you know that there's gonna be when you brake, there's gonna be some sound energy. You know, when you see like a car moving really fast and suddenly stops, it's gonna be like like that. That sound energy, okay? So some of the kinetic energy was gonna be converted into sound energy, and the friction, the rubbing of the tires against the ground, that's gonna cause heat energy, okay? So basically, the kinetic energy that the car was moving, you brake, the braking is gonna cause some sound energy, and the rubbing between the tires and the ground is gonna cause heat energy. So you're gonna say that some of the EK some of the EK from the car is converted into sound energy by braking, and some to heat energy due to the that's not very good. Due to the rubbing of the tires on the ground. Okay, so basically you have to say to get a merit grade here, so merit is the highest grade. To get a merit here, okay, you're going to be saying that some of the kinetic energy is converted into sound energy and heat energy, okay, by the rubbing of the tires on the ground, okay. And you have to say that the principle of energy conservation is that energy is not lost, okay, but is instead transferred into different forms, okay. So you need both of these to get a merit grade. And to get an achieved grade, you can either say what the principle of energy conservation is, or you can say that some of the EK was lost into sound and heat energy, okay. So either one of these will get you an achieve, but you do need both to get the merit grade, okay. So achieve for any one of this, okay. Alright. Calculate the average rate, okay, at which the brakes transfer energy as the car slows from a velocity of 18 meters per second to a velocity of 11 meters per second in a time of 6 seconds, okay? So basically, okay, it says calculate the average rate at which the brakes transfer energy, okay? So you know that, so basically how am I going to explain? So you have to find the amount of energy that is transferred. So what's missing, we need to find, energy, okay? We want to find the average rate at which the brakes transfer the energy, okay? So you know that, power equals to work over time. So basically, we're not going to say work, okay? So we're going to say that power equals to energy over time, okay? So change in energy over time, okay? So because it says find the average rate, okay? So when it says you have to find an average rate of something, so it's going to say, so for example, I'm pushing something. So I am pushing something, and then there's a change of 500 joules in 5 seconds. So the rate would be 100 joules per second, okay? So that's basically just trying to tell, so what it's saying, the average rate is of the brakes transferring energy is basically just asking you to find the power, okay? So don't get confused by the wording of the question. It's basically by saying the average rate, so you know that P equals the change in E over T, okay? So basically it's just trying to want you to find out how much power, okay? So how are we gonna do this, okay? So we know that so we're gonna find the EK, okay? So EK of both situations, and we're gonna calculate the loss of EK, okay? So basically we can say that EK equals to half mv squared, okay? So we know that the mass is all the way up here. It says that the mass is 1100 kilograms, okay? So we'll say that mass is 1100 kilograms. Okay, and we have speed, V's 18 meters per second, okay? So you can say EK, initial EK equals to half of 11,000 times 18 squared. Okay, so that should give you, what should I give you? Sorry guys, this calculator. And that equals to 178,200 joules. So the initial EK was 178,200 joules. So now the final EK, so we can say initial EK, and we can say final EK equals to half 1100 times 11 squared, okay? And that should give us 0.5 times 1100 times 11 squared. That gives us 66,550 joules, okay? So now we can say that change in EK equals to final. Say that, yeah, we can say that, change of the EK equals to, so change in EK. Yeah, it's initial EK minus final. And this equals to 178,200 joules minus 66,550 joules, okay? And that should give us change in EK equals to 111,650 joules, okay? So now we can say that change in E now, okay? So basically it tells you the time is 6 seconds, okay? So we know T equals to 6 seconds. Change in E equals to 111,650 joules, okay? Power equals to question mark, okay? So you know that power equals to change in E over T, okay? So basically we can say power equals to 111,650 divided by 6. And we plug this into our calculator, okay? plug this to our calculator. We should get ourselves. This should give us 18,608.33 watts. Now you can probably just round that to 18,608 watts. Okay, and that should be your final answer. So that's the rate of change of the energy transfer. Okay, so basically it's saying that 18,608 joules of energy was lost per second. Okay, so basically I mean you could write, so you see how I used watts here, right? So saying joules over seconds is the same thing, because you know P equals to change in E over T. You know T is measured in seconds, and then change in E is measured in joules, right? So therefore you can say P equals to joules over seconds, right? So that's, you can write that as a unit as well, because that's joules over second is basically just changing E over T, right? So basically it's saying that 18,608 joules was lost, was transferred, or as you can see what the question asks is, so the brakes transferred, okay, the brakes transferred 18,608 joules per second, okay? So if we multiply 18,608.33 was the answer by 6, you should get 111,650 joules, okay? So basically power is just what is the rate of transfer of the energy, okay? So basically how much energy per second, okay? So for example, I'm lifting weights at the gym, okay? So let's just say how much joules of energy can I do in a second, okay? Okay, so that's basically saying like what is the rate of my energy transfer, okay? Hopefully you understand that, okay? We didn't understand, we might have not covered this in depth, okay? So hopefully you understand what the question is asking and how I got to my final answer, okay? So getting to your final answer is 18,608 watts, or 18,608 joules per second. That will get you an excellence grade, okay? That's and with all the working, okay? To get a merit grade, okay, you're finding the correct. So you're finding the 11,000. No, why do I keep saying 11,000? 111,650 joules, okay? So that's finding a change in E. That will get you a merit grade, okay? To get an achieved grade, okay, you're finding the correct kinetic energy. So you could say you can find the correct initial EK and you're finding the correct final EK. That's going to get you an achieved grade, okay? Alright. I think that's it for this test. That's it. Hopefully you understand everything in this video, okay? Hope you enjoyed. If you have any comments, please leave it in the comments below, okay? I'll see you in the next video, okay? Thank you. Bye.